start working through this bell work. What is the very first thing we're going to need to do on this first one here? What do we need to do first? Say it again. Yeah, we need to multiply everything on the right by -1 because what we need to do is we're going to distribute this minus sign. I need to make sure we subtract our 4b squared and that we subtract -2. So when we have subtraction, I need to distribute that minus sign through. Make sure we are subtracting both pieces. So our 7b squared and our 6b minus 7, those guys are all staying the same. Then we're going to subtract our 4b squared minus -2 becomes a plus 2. So we got to make sure we're watching out for those pieces. When we have subtraction, we need to distribute that through. Make sure we're subtracting everything. Now what do we do? Combine like terms. That's all this is about. This is all about trying to find like terms. So we do have some like terms here. I've got a 7b squared and minus 4b squared. B squared is the same term. I can combine them. They are alike. So if I have 4b squareds and if I have 7b squareds and I take away 4b squareds, it's going to leave me with 3b squared. 6b doesn't have anything it can join with, so I'm just going to bring down the 6b. It doesn't have anything to combine with, but it's a term. And then our last term is our -7 and our +2. Well, -7 plus 2 is going to give us a -5. So our final answer on this, our solution, is this guy here, 3b squared plus 6b minus 5. Questions on that one? Okay, what do we need to do first on the bottom one? What do we do here? What do we do? I don't make anything. Okay, right. Say it again. Couldn't hear you. Combine like terms. I don't need to distribute anything on this one. It's addition. We're just plussing these together. So when we're adding these two polynomials together, I don't have to distribute a minus sign through. We don't have a minus sign. So we're just looking to combine some like terms here. My parentheses aren't actually doing me any good. I can just kind of work around them. So if we look to see my f squareds, I've got -2f squared and -2f squared. So that means we have -4 f squareds. That's I borrowed 2 from you at one time and I borrowed 2 from you another time. All together, I owe 4. Same thing with our f's. We've got -3f and -3f. If I borrow 3 from you one day and I borrow 3 from you the next day, all together, I owe you 6 of them. And then our last term, our -5 and our +8. That's going to give us a +3. And that's our answer. Switching it to yellow, so it's actually highlightable. Questions on those? Please do. We don't need to distribute on this one because it is a plus here. If I was to distribute a plus, it's just like timesing by 1. So we don't have to distribute everything. When we're just adding and subtracting, it's just combining like terms. Only when we're multiplying do we need to distribute over. So make sure we're paying attention to that. I've had a lot of people run into that issue when we were doing our complex numbers, dealing with the parentheses with stuff with I. We would add when we should multiply or multiply when we should add. Be careful, because we've been making that mistake. Not frequently, but not infrequently either. And it's happened with multiple people. So just be careful. If it says subtract, do not multiply. If it says add, do not multiply. So make sure we're paying attention to these little symbols. They are important. They tell us what to do. If it doesn't have a symbol in between, that's when we multiply. Like, oh snap, say like this. This is when we multiply, when they're smushed together like this. Or if it has a star or a times or a dot. I know we started this one yesterday. We got about halfway through it, but I want us to talk through it again, so I'm going to do the whole thing. So we're going to look at page 12, number 5. And we got about halfway through it in the video yesterday, but just instead of trying to speed run it and do it halfway, I'm just going to start from scratch, so you might have half of it written down. If you finished working on it, I love it. Double check that we get it right. So when we have these pieces, multiple pieces like this being multiplied together, a lot of times we're going to have to do a couple of rounds. So remember that our parentheses work like stop signs. So I can't just come through and distribute this 3a plus 5 to everybody here. I'm going to take my 3a times 1 chunk. We're going to look at 2 chunks at a time. So looking at this one here, I can't just start going distribute-a-palooza. That's not something we're going to do. We need to look at this in smaller pieces. I'm only going to look at 2 pieces at a time. So I'm going to start by looking at just these 2 guys right here. I don't know why it keeps trying to make me use the highlighter. I'm going to look at just these 2 pieces here. And if I multiply together my 3a plus 5 and my a minus 7, just looking at these guys, we can do this multiplication however we like, whether we want to use the box, if we want to use our double distribution, if you want to use FOIL, whatever method we have. I tend to use double distribution because it is easy to kind of modify when we have different numbers of things. That's what I'm going to take my 3a times a to get a 3a squared. I'm going to take my 3a times this minus 7 to get minus 21 times a. So that's taking my 3a times both pieces in that a minus 7. So 3a times the a and 3a times the minus 7. Second round of distribution means I'm going to take that second term, that plus 5, and I need to take it times both pieces. I'm going to draw it on the bottom. 5 times a is going to give us a plus 5a. 5 times negative 7 gives us negative 35. So I can multiply those pieces together. I'm going to come through and I'm going to do some combining of like terms because we can simplify this a bit. When I combine my like terms, what we get is 3a squared minus 21 plus 5 is going to give us a minus 16a minus 35. Questions on that process right there? That's not the end. It's about as far as we got yesterday. Because again, remember that this piece here is just these 2 pieces combined. So this isn't my whole problem. That's just these 2 guys. So really, my problem still looks like this thing times our third piece of there, times that 4a plus 1. I multiplied those two together first, because now I get to do the whole cycle again. I need to take and do some distribution. I'm going to need to multiply my 3a squared times 4a and 1. I'm going to take my minus 16a times 4a and 1. I'm going to take my minus 35 times 4a and 1. I'm going to take everybody times that second term. Again, you can set this up with our distribution. FOIL gets a little messy on this one. You can do it with a box. If you are a box person, this would be I have 2 terms in one side, 3 terms in another, so it would look kind of like this if you did it in a box, which is absolutely a thing we can do. I'm going to do it my distribution style. Both ways work, totally fine. But I'm going to take my 3a squared times my 4a, and that's going to give us 12a to the third. Then I need to take my 3a squared, that's not the pen I wanted, 3a squared times 1, so plus 3a squared. Then I'm going to take my minus 16a times both of those pieces. So my minus 16a times 4a. 16 times 4 is actually 64. So this becomes minus 64. A times a gives us a squared. And then we're going to take our minus 16a times our 1. So we get minus 16a. One more set to go. I've got my minus 35 times 4a. 35 times 4 we will type into the calculator. It's not one we are expected to know off the top of our head, but it would be minus 140a. And then also our minus 35 times 1, we get minus 35. So we've done all this distribution now. So when we have more than 2 pieces, it's very easy to take our double distribution and modify that for when we have 3. In the box, we just need to make an extra column to put our 3. So just be careful if we have more than 2 terms, that we make sure we're doing all those multiplications. The benefit of also doing it in our double distribution is it does, a lot of times, put our like terms next to each other. If I did my 3a and then my 16a and then my 35 all times the 4a, it would get things scrambled. It totally works, like it doesn't matter. But if you do it in this double distribution order, our like terms are going to be right next to each other for the most part. So when we come through here to combine our like terms to get our final answer, we're going to wind up with our 12a to the third, or a cubed. I've got my 3a squared and my 64a squared. That's going to give us a minus 61a squared. 6 is bizarrely small. There we go. Our next set of like terms, we've got our minus 16a and our minus 140a. That's going to give us a minus 156a. And then our minus 35 doesn't have anybody to combine together, so it just is minus 35. And this is our answer. That is fully multiplied out, fully simplified. That is as far as we can go. There's nothing else we can do with it. Questions on this one? I know we started it yesterday. We're going to do another one very much like it. We're going to do the one next to it, number 6. questions on that one? Okay, number 6 is very much like it, even though it does not look like that. This looks like just 2 pieces. But what we need to notice is we do actually have a exponent in here. So before I do any multiplying, I'm going to write this out long ways. Because x minus 3 squared, that's the same thing as x minus 3 times x minus 3. And then times x plus 2. So this does have 3 sets of parentheses, just like the last one did. So I'm going to take my time here to rewrite this out because it will make things easier to work with. So instead of having my x minus 3 squared, I recommend rewriting it as our x minus 3 times x minus 3, and then times our x plus 2. That means the same thing as x minus 3 squared. Then I don't have to lose track of where my exponent is, and we won't lose track of the middle term because when we do it as a squared, as an exponent, 9 times out of 10, we get it wrong. Please stop trying to distribute your powers. We can only distribute when it's multiplying, not exponents. Then we're going to do this exactly like we saw in the last one. I'm going to take 2 of my parentheses, and we're going to deal with them first. So I'm going to look at my x minus 3 times x minus 3, and I'm going to multiply them first. It genuinely does not matter which pair you pick to multiply first. If you wanted to do x minus 3 and x plus 2, that's totally fine. It does not matter what order we multiply in. Just like 2 times 3 times 4 is the exact same thing as 4 times 3 times 2. Doesn't matter what order we multiply in. I can pick whichever pair I want. I just tend to pick the first 2 because I'm lazy and I like to follow patterns. So treating this just like we did the one in the last one, I'm going to take my x minus 3 times x minus 3, and I'm going to multiply that together first. And then I'll bring it back in with the x plus 2. I'm going to group. Make this just a smidge bigger. We're going to work with this guy first. And we're going to treat this with our distribution just like we did before. Again, you could box, you can FOIL, whatever technique you want. You'll get this in pieces either way. But we're going to take our x times x, and we get x squared. And then we're going to take our x times minus 3 to get minus 3x. Then what we're going to do is we're going to take our minus 3 times x to get another minus 3x. And we're going to have our minus 3 times minus 3. Minus 3 times minus 3 gives us a positive 9. So be really careful when we're looking at this multiplication, because when we combine our like terms here, what we should get is our x squared minus 3x gives us a minus 6x plus 9. So our x minus 3 as a quantity squared is not the same thing as x squared plus 9. So please stop multiplying them out from here by giving me x squared and 3 squared. No. This is what it's going to be. But again, remember that this is just this pink pair up here, just these guys. This piece, when multiplied out, gives us that x squared minus 6x plus 9. We still need to multiply that by our x plus 2. And again, you can do this with your distribution. You can do this with the box. We'd have a 2 by 3 box because we need to make sure we have all 1, 2, 3 terms here and 1, 2 terms here. So you'd have 6 boxes, 6 squares in your box. Totally valid. You can absolutely use that. You could use FOIL as kind of a guide. Just make sure you're catching that middle term as well. But we're just going to multiply these together, trying to catch any of our pieces that we can. So when we multiply this together, we're going to have our x squared times x, giving us an x cubed. We're going to have our x squared times the 2 to get a 2x squared. Then we're going to have our minus 6x times x to get a minus 6x squared. And our minus 6x times 2 is going to give us a minus 12x. One more set. We're going to have our 9 times x giving us a plus 9x. And our 9 times 2 giving us 18. So take your time on these. Write all the pieces out. If you need colors, if you want to color code stuff, please let me know. I have highlighters, colored pencils, markers, anything you need. I can help you color code it. If that helps you, do it. Make sure we're drawing our arrows or connecting pieces, or at least keeping track so that we have the right things. When we multiply it out fully, we should have 6 terms here. Then we need to combine our like terms together because that's how we get our answer. So looking through here to combine our like terms, I've got my x cubed. It doesn't have anything to combine with it. Then we've got our 2x squared minus 6x squared. That's going to give us a minus 4x squared. Then we've got our minus 12x plus 9x. Minus 12 plus 9 is going to give us a minus 3x. And then our plus 18 is just hanging out on the end. And this is our fully simplified answer. So don't try and do this multiplication all at one time. It does not work well. We're going to be slow, cautious, and keep track of what we're doing. Whether we do it with distribution or do it with a box, it does not matter. We just need to keep track and make sure we're staying organized. These get kind of messy every now and then. Again, this is something that you can do with a box. If you wanted to multiply this with a box, I'm just going to draw it up here. Your box would look like this, where we'd have our x plus 2 times our x squared minus 6x plus 9. So you'd have to set your box up like this. That's definitely something we can do, and that's absolutely valid. Doing it with distribution also works. Just make sure you're keeping track of what you're doing, going through it carefully, and being organized. The most common mistake I see on these is that we just skip one. Like we just straight up miss a term. That's the most common mistake I see on these. So it's really about going slow, being careful, and being intentional. We got one more multiplication to do. It is the biggest one. It is on the next page at the very, very top. We have a trinomial and a trinomial. So we have 3 terms times 3 terms. This is one go. We are not going to have to do this in 2 rounds multiplication. It's just one really big one. Because when I distribute here, if we do this with distribution, I need to make sure I take my first term times all 3 pieces here. And I need to take my second term times all 3 pieces here. I need to take my third term times all 3 pieces here. This is another one. We could absolutely do this with box multiplication. Box totally works. But in this case, since I have 3 terms times 3 terms, your box is going to look kind of huge. Because you would need to set up box multiplication very much like this. which totally works. You absolutely can do this. And if you would want to do that, you'd put this like with our 2x squared minus 3x plus 1 and our x squared plus 4x minus 2. 100% valid, totally cool. You will get the same answers that I do. It also works to do this with our distribution, where I'm going to take my 2x squared times all three pieces, and my minus 3x times all three pieces, and my 1 times all three pieces. I'm just going to scooch this down. So when we do this with our distribution, I'm going to take my 2x squared times my x squared. What is 2x squared times x squared? 2x to the, careful, x squared times x squared to the fourth. We add our exponents when we multiply our bases. So 2 plus 2 gives me 4. Then I also need to take my 2x squared times 4x. 2 times 4 gives me 8. X squared times x, that's 2 plus 1, or x, 2x's plus 1x, gives us 3 x's. And then I also need my 2x squared times minus 2. So that gives me a minus 4x squared. So taking my first term times everything in the second trinomial, already I have 3 pieces here. This is going to be big. This is exactly the same items we would have in this first column here, the way I set this up. So if you are a box person, this is exactly what you would have in this first column. Doing the same thing with our second term, taking this minus 3x times our x squared. That's going to give us a minus 3x to the third. Because I have x times x squared. And then we're going to take our minus 3x times 4x. Well, minus 3x, or minus 3 times 4 is going to give us a minus 12. And x times x gives us x squared. Minus 3x times minus 2. Well, minus 3 times minus 2 gives us a positive 6. And then I have an x, because that was minus 3x times minus 2. And then I have one more set to go. This one's a big one. So we're going to have our 1 times our x squared. So that's going to be plus 1x squared. And I'm coming on to a second line here. And that's okay. We can use that when we're combining things together. And then I'm going to have my 1 times my 4x. We get plus 4x. And then my plus 1 times negative 2. So we have minus 2. Lots of pieces. And again, that green section would match that rightmost column. The blue section would match the center column. So these are exactly the same pieces we get if we went through this way. I don't care which technique we use, but you need to use something to keep yourself organized. Because this has 9 pieces that we need to have, and we have to have all 9 or it's wrong. These 9 pieces are going to combine together to make a shorter polynomial, but these 9 pieces are the foundation. This is where it came from. These 9 pieces are very important. From here, we're combining our like terms together in order to get our final answer. So combining our like terms together, we're going to have our 2x to the 4th. It doesn't have anything to combine with. My cubes, I've got my 8x cubed minus 3x cubed. Well, 8 minus 3 is going to give us a 5x cubed. Looking at my x squareds, I've got a minus 4x squared, minus 12x squared, and plus 1. So I have 3 pieces to combine here together. Well, minus 4 and minus 12 It's going to be minus 16. Minus 16 plus 1 gives us a minus 15. Minus 15 x squared. Then looking at our x's. I've got a 6x plus a 4x. So it gives us a 10x. And then my minus 2 doesn't have anybody to combine together. So when we're working with these big, super gross, not going to ask you to do tons of these because holy cow are they long and gross kind of polynomials. This is a lot about keeping yourself organized. Do not try and speed rush it or panic through it. We combine our like terms as far as we can, and then we stop. I cannot go farther. Once we have it down to just one of each flavor, so they're all related, they're all very similar, they're all from X's, but again, this is an apple and an apple pie and an apple tree and an apple fritter. Similar, they're all from the family of apple products, but they are not, or in fact actually probably more like apple, apple pie, apple tree, and then an apple iPhone. Apple products, they're all parts of apples, but you cannot put an iPhone inside my tree and say, thus I have made you a new tree. You have more apples. I cannot smush together and add or subtract together things that have different exponents. They have to have that same exponent for me to combine them together. So please stop taking polynomials that look like this and smashing them together to make one term. Do not take 2 plus 5 minus 15 plus 10 minus 2. Leave here. Stop there. That is answer. Okay. So working with this multiplication, being really, really careful with it, doing what we need to do. Questions on this one? That gives you everything you need to be able to do homework 3. So what I'm going to do is I'm going to stop right here. I'm going to pass you guys back out your skills checks for Monday. Got those graded and in. And I'm going to pass back everything I've got for you. So I have a couple other things that I need to pass back. Use this time to work. Ask questions. I'm here. We don't often get a ton of time where we have question time. But, you know, we got it today. So finish out homework 4-3. It is due tomorrow, but you guys have 9 minutes where you can work on it. If you need another copy of it, as usual, they are up here in the Algebra 2 bin. So I'm going to pass you guys back your skills checks and anything else I have for you. I'm going to put everybody's upside down. It is not an indictment of your score. I'm going to look at the scores in front of you. that should be everything I have for you guys. So let me know if you guys have questions on anything. I'm happy to help. Tomorrow we're going to start working on dividing. We've done adding, we've subtracted, we've done multiplying. Tomorrow we'll start on division.